What's up? What's up? It's your man Jimmy Chan. All right, so here is another rational function that I need to graph. So let's go ahead and graph this, okay? So first, I need to find my x-intercept. Well, what do I know about x-intercept? My y is equal to 0. The only time a fraction is equal to 0 is if the numerator equals 0. So what I can do is just say, okay, x minus 2 has to equal to 0. What would make it 0 is when x is equal to 2. Great. So that means I have a point 2, 0. All right. Next thing I want to do is find that y-intercept. What I know about that is that x is equal to 0. Great. I got 0 on top. Actually, negative 2 on top when I put 0 in there for x. What's on the bottom when I put 0 in? Let me see here. 0 squared minus 0 minus 30 will be negative 30. So this is actually going to be giving me a 1/15. And of course you're like, oh no, how do I graph 1/15? It's okay. It's okay. We're all gonna be okay. But I do know that my y-intercept is at 0, 1/15. All right, great. Now I have two things left. I have the vertical asymptote and the horizontal asymptote. So let's go ahead and deal with the horizontal asymptote really quick. Horizontal asymptote is where I compare the highest power on top versus the highest power on the bottom. So if you look at it, the top has the highest power of just x. The bottom has the highest power of x squared. Okay? Since the top power is less than the bottom power, that tells me that I have a horizontal asymptote at y equals 0. All right? So now to my vertical asymptote. Well, vertical asymptote is based on the restriction, which is x squared minus x minus 30 cannot equal to 0, right? So when I factor this, there's going to be x plus 6, and x minus 5 is going to equal to 0. So I have x equals negative 6 and x equals 5. Okay. So if I was to graph this, so I'll have a vertical asymptote at x equals 5, 2, 4, 5. And I also have one at negative 6, 2, 4, 6. Ooh. And there we go. All right, so I have those two vertical asymptotes right there. I have, let me see here. I have a y-intercept, horizontal asymptote at y equals 0. I'm going to make that one, let's see here, white. It's kind of cool. Let's select that and make it dotted. There we go. All right, so I see my horizontal asymptote, and I can plot my x-intercept as 2, 0. My x-intercept as 2, 0. And my y-intercept as 0, 1/15. There it is. It's very, very, very close, right? All right, so now what I need to do is kind of build tables around my my vertical asymptotes, okay? So here we go. Actually, I think that would be, that's probably, could go up. Hey. Let me see, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. How do I want to do this? And then I need this piece right here. Right, here's my X, here's my Y, and I need both this one twice. Right? One is going to be when my vertical asymptote is at -6, and one's going to be at 5, right? And both of these are going to have my vertical asymptote during that time. Okay? So I want to make sure I find 2 to the left, 2 to the right. So with -6, it's going to be -7, -8, and then -5, -4. And with 5, it's going to be I went to the left, so 4, 3, and 5, 6, and 7. Okay? So that is what I want to look for. And one of the easiest way to do this is actually through Desmos. So I'm going to go ahead and lift this up, and I can actually enter it. Let me see, let's use -8, okay? So let me go in Desmos here, and let's go ahead and clear everything. I'm frozen. Oh, there's clear. Clear it all. Okay, so I have a -8 minus 2. Actually, let me delete all of that division. -8 minus 2 on the top, and the bottom is going to be parentheses -8 minus 6, open parentheses, -8 plus 5. Okay, let me double check. So x minus 2 on top, x minus 6, x plus 5, right? X minus 2, x plus 6, x minus... Ooh, I did that incorrectly. This is -6 plus 5, so this is positive, this is negative, so this is negative, and this is positive. Right? Let me put these in black here. And this is going to be a -5, and this is going to be a +6. There we go. Okay. We're back to work. But anyways, it is x minus 6, x plus 5. X minus 6, x plus 5. So this right here tells me is 5 over 21, or let's go ahead and do -0.24. Ooh, shoot. So let me go back and do -7. -0.35. -0.35. Now let's do -6. -0.67. -0.67. -4. +0.6. -3. +278. Now I can do the positive 4, 5, 6, 7, 8. Okay. So 4, 4, 4. negative 0.11. Now let's do 5. Negative 0.3. 7. Positive 0.42. And now 8. Point 2.3. Okay, so if I was to plot this, right, at 8.23, that's about a quarter, and then at 7 is 0.42, which is about 0.5, okay. At 5 is going to be negative 0.3, so about a negative 1/3. And then at 4 is even smaller, makes sense. At negative 3 is going to be about a quarter. At negative 4 is a little bit more than a half. At negative 6 is going to be negative 2/3. And negative 7 is going to be a lot less than that, okay? So what this is showing me is more of the curvature, okay? So I'm going to just keep it simple here, all right? So if you look at this curvature right here, what this is showing me is something like that. Oops. I know it doesn't look exactly like it, but it's close, okay? So it looks something like that, where this one here is probably gonna look something like this, where something here, ooh, actually, this is probably gonna look about the same as well. And then over here, down here, it looks like that it's going to actually cross over to the other side, okay? So it looks like that this is actually going to go ahead and connect these two here, okay? So that's the thing, is that these numbers here that we just figured out is more about the curvature around my vertical asymptotes, right? So from there, I can look at my graphs or my choices and say, okay, it is going to be choice D. Okay, and there you go. I hope that helps. If there's any questions, please let me know. See ya. Bye.